So welcome to our discussion today, folks, of Module 10. So network management, and in particular, we're going to look at some of the different technologies we use for network management. It's funny because CDP, or Cisco Discovery Protocol, which is the proprietary Cisco Layer 2 protocol, was in the curriculum 2 curriculums ago, got taken out, now it's back in. So CDP is in many cases, if you read much about it, you will read that people consider it to be a security hole. I'm going to start packet tracer here. Packet tracer. I don't even know what version's on my machine. It's an older version. But I'm just going to go ahead and put in a 4331 and throw in, no, don't do that, negative. And I'm going to throw in a raw switch here. And yeah, I know it's packet tracer, but for what we're doing, it'll work. I'm going to do a straight through cable from gig 001 for internal to gig 01. I'm going to go in here and I'm just going to type new. Can y'all see my packet tracer?
No, I'm still seeing the.
Okay, let me go back then. I'm sharing the wrong way. Let me share my screen instead of the document. Now you should be able to see it.
Yes, it's there.
Okay, so I'm gonna go in here, int GI 001. By the way, a lot of times I use 001 just because for internal, I'm doing internal things, no shut. And so you bring it up and you see now that it's going through spanning tree, blocking, listening, learning, forwarding. So also important concepts for the CCNA. But once this is up and running, one of the things you can do, if you go in here and do show CDP, you'll see that by default, CDP is on globally on this router. So show CDP information. You see it's sending CDP packets every 60 seconds, whole value 180, and CDP version 2. CDP is a layer 2 protocol. So that's very important because you don't even have to have IP addresses set up between 2 devices. So I go in here and I'm gonna just throw another, let me throw another router on here real quickly. I'm gonna throw another router over here and I'm gonna put, let's do a crossover, even though I know it'll auto cross, but let's do gig 000 for outside, gig 000, and bring those 2 interfaces up. So I'm gonna bring those up and I'm gonna do int GI 000, no shut. And of course the other, it won't come up until the other side's up and running. So let's do T and GI 000. All right, no shut. So that's going to come up and run now. But you'll notice there's no IP addresses on this thing. So at this point, if I do a, let me actually put a name on here just so you can, this host R1, and so do right. Let's go over here. I'm going to give this a name, host R2, do right. And you don't have to do the right, but I'm just doing it for poops and grins. All right, so show IP int brief. You'll notice there are no IP addresses on this. So gig 000, which is being shared between router 1 and router 2, there's no IP address assigned. But if I do a show CDP, you'll see that CDP is enabled. I do a show CDP neighbors, you'll see that I have a neighbor, and that neighbor is a Cisco 4300 series router, and it is on the local interface that it's off of is my gig 000, and I'm connected to that router's gig 000. And it tells you this is a router, so it's R. So even though there's no IP addressing going on here, because you have layer 1, layer 2 connectivity, which remember that's what this means. This is up, up. The first up is your layer 1 connectivity. The second is your layer 2 connectivity. So we're sharing, in this case, we're running Ethernet across these 2, but I'm able to see. Now you'll notice I'm not seeing the switch, and that is because it will only, CDP can only show you directly connected neighbors. This is pretty useful when you have this though. So if I do a Control Z, show CDP neighbors, all right, and you can see now that you've got a switch, a device ID switch on my gig 001, my local gig 001 on the router, is connected to a switch that's a 2960, and it is hooked on that 2960 to port gig 01, which if I hover here, it would show you that, and you would see that that is true. Actually, I'm gonna do one thing here, folks, while I got y'all, while I'm here. I'm gonna enter this and see if I can't. I'm gonna pull out, I'm gonna try something while we're all sitting here, and just for poops and grins. This is a pod I've been working on that is CML, Cisco Modeling Labs, and I am working on having the ability for y'all to access these inside of NetLabs. And actually, I'm gonna give y'all access to it so y'all can play with it. But this is the new CML tool, CML Personal Edition that I've got in here. I'm gonna create a new lab, and I'm gonna pull out we'll build exactly what we got in the other. Let's go here, IOSB, and iOS layer 2. And then I'm going to connect these. Now, the only thing that's going to be different is our interfaces will be a little different. So, but on the router iOS v2 switch, we'll do internal, so gig 00. And then on this, we'll do gig 00 to gig 00 on the two routers. Now, I'm going to boot these, and you just click right here to boot it. And this starts booting the iOS image that is associated with these devices. And the cool thing is, I can now get rid of those, oops, and now get rid of that lab manager, and I can minimize or make this much smaller and get it out of the way. So we got room to look here. And then I can actually go and look at them booting. And this is the real Cisco iOS. It's just booting on a virtualized machine, which makes it better than a simulation because it's not a simulation. It is the actual iOS image booting. And so that's what this allows us to do, which is very, very slick. And so you can see it's booting here. I'm gonna let it boot, and we'll come back to it in a little bit because I want to see how CDP works on this versus just Packet Tracer. But back over here on Packet Tracer, we've got our setup of two routers and a switch. And on the switch or the routers connected to the switch and the router, you can see it even shows you the name of the switch. You know, see how it actually picked up on the name being R1. And so now it says that R1 is off of my local gig 000. Now you can drill down even better. You can go show CDP neighbor detail. And when you get in the detail, take a look at this. This tells me that I'm connected to a router called R1. It even tells me the name of the iOS that is on that particular router. All right. So it gives me those details. If let's say I was connected to R1, this is something really, really cool. I know I say that a lot, folks, but I like routing. Let's imagine I was connected to a router that was upstream of me, and my ISP did not tell me what the IP address was on it. Okay, so I'm connected to router 1. Let's imagine this was actually my ISP. So this is ISP. Right, I'm gonna go in here and change the host name to ISP. But for whatever reason, my ISP forgot to tell me what my upstream IP address is. So I'm setting up a branch office, and I don't know what that IP address is. Well, if they're both Cisco devices, I could do a show CDP neighbors detail, and I can do it's still trying to get that information, but let's do a show CDP neighbors. You can see now that it's trying to time out that R1, which it will eventually do. And it will eventually get rid of it there. Yeah, still got it in there, but eventually after 180 seconds, because if you see show CDP, you'll see it's 180 seconds for the whole time. So that R1 stays in there even though that doesn't exist anymore until the hold down timer goes away. And right now we're at 91 seconds, 87 seconds, so in 87 seconds. But when you do a show CDP neighbors detail, take a look now what it tells you. It even tells you the IP address that's on the interface that's connected to you. So if I didn't know it, this is one way they give you a test sometimes of giving you a single device and saying that you've got CDP, and then you've got to build using just CDP an entire view of the network. And that's something that's been done for us for ITQ qualification. They'll give you a network. They won't give you any of the connections. They'll hide all of the links. And it's your job to figure out who's connected to who. Excuse me, we can just do show CDP, neighbors, show CDP neighbors. And that will tell you that, hey, off of my gig 001, there's a switch that's a 2960 switch. Off of my gig 000, there is a router, and it looks like there's 2 routers off my gig 001, and we could clear it, but it'll be done in here a second. 17 seconds, it'll clear out. And you will see that there's a router called ISP, and I'm connected to its gig 000. So you could go through and actually draw out a network map using CDP. But again, notice it's only directly connected neighbors. If you do the ISP, you're not going to see the switch because you're not directly connected to it. Let's jump back over to our CML lab and let's see what we got here. This thing's already up and going. So let's do I'm on the one on the far left here. And let's do this. Let's undock this, make it bigger. Okay. So we get a whole lot of, and I'm interested in seeing how CDP is going to actually work on this, because let's see if CDP is enabled. Show CDP. Yep, CDP is enabled. Show CDP neighbor. And we're seeing nothing at the moment. Because I'm actually interested in how layer 2 works inside of, there's some funky layer 2 stuff going inside of CML. And we're going to have to do some things to figure out exactly how CDP and all these other things are going to work. But you can notice I'm connected gig 00 to gig 00 between these 2 routers here. Yep, it's not showing up. Let me make sure it's actually enabled on this other one, which it should be. Nope, I mean it's enabled, but it's not showing. Showing it. CDP version 2 and they're enabled. You know what? It's because I'm a doofus. Guess what, folks? If your interfaces are not up, then you can't have neighbors, can you? And see, that's why it's good for me to show y'all that even people who seem to know what they're doing forget simple things. And by doing, you'll notice one thing I did a show IP brief. And the second I saw administratively down, well, there's no way layer 2 is going to work if layer 1 is down. So now I can go back over here and I can do a Control Z. Actually, let me give it a name. I'm going to give it a host name of ISP, just like the other one. And I'm going to go do right. And I'm going to do a Control Z. As soon as that's done, I'm going to show CDP neighbor. And you'll notice that now I am connected to a device called router off of my gig 00, and I'm connected to its gig 00. And for some reason it sees it as both a router and a bridge, which is funny. And that's more than likely because of the CML interface. But let's do host R1. And if I do a show CDP neighbors, oops. By the way, one of the things you should always do too is do line con 0 logging synchronous always, because you're going to mistype things. And then you just show CDP neighbor, and you can see that I'm connected to a router called ISP or router 2, but you notice there's still a hold time there, so that's where we learned the first name of it. And then insert host name here is actually the switch. That's the name of this switch, which is what they use as the host name to begin with. And you can see that this is connected to a router called R1, which is also called router because that's where we renamed it. So it's waiting. I'm going to do a config T, host name S1, control Z. I'm actually going to say clear CDP question mark. Clear CDP question mark. There it is. Table. All right, now I knew there had to be a way to do it. And so now it got rid of that, immediately got rid of the old name of router. Same thing here, we'll do a show CDP neighbors. We're still seeing the old name, so we'll do a clear CDP table. Golly, I can't type. Then we do a show CDP neighbors, and boom, we've got, well, should have got rid of the table there. There it goes. It took it that time. Now it's just taking time to learn. So every 60 seconds it sends it out, so it takes 60 seconds to learn it. But this is a layer 2 protocol that is Cisco proprietary, and it allows you to learn about what's connected on directly connected links. Now, it is possible to disable CDP by doing no CDP run. That's the global command. Be aware though, if you do no CDP run and then try to turn it on an individual interface, CDP enable, it will not turn on. So once you globally turn it off, it's off globally. So again, I can go back into here and I can go config T, and I can go no CDP run. And at this point, do show CDP, and CDP is not going to be enabled. So even if I went in an individual interface, let's say gig 000, and I tried to do a CDP enable, okay, if you do a do show run, you'll see that CDP enable does not go on that interface because globally CDP has been turned off. And you can even see that inside of the running config right there, no CDP run. If you want to turn CDP off on an individual interface, what you do is you do CDP run, which turns it on globally, and you go into the individual interfaces and you do no CDP enable. All right, which I know is a negative command, but that's just exactly what it is. So now if you do a do show run, CDP is still enabled on other interfaces, but it's not enabled on the gig 000. So that would be what you would do typically towards your interfaces that are going out to the internet or to non-Cisco devices. Which brings up an excellent point. Is there a way to have this functionality with non-Cisco devices? And the answer is yes. There is a protocol called LLDP, okay? So we'll go through next page here. Link Layer Discovery Protocol, or LLDP, does the exact same thing as CDP, except for the fact that it is not Cisco proprietary. So you can have other devices running different operating systems, and LLDP can allow them to send information between one another. So you can do LLDP run. And by the way, by default, let's go look out here on a real router. Let's do show LLDP. And by default, it's not enabled, but you should be able to do config T, LLDP run, and then do show LLDP. And you can see the LLDP is now active. So I could put in a non-Cisco device, and I can even do, if you enabled LLDP on both sides, okay, actually I'm already there. Let's go back to ISP here. I do config T, and I do LLDP run, control Z, show LLDP neighbors, and you should be able to see now that LLDP is turned on both R1 and on this ISP, they just start sending information at the same time. I wonder if there's a yep, there's a detail command. So yeah, LLDP, it tells you what it is. You can tell you the chassis identifier, which is the MAC address. Gives you the iOS version. So LLDP basically has the same capabilities as CDP. I would know LLDP and how to turn it on and off globally. I would also know the commands on how to set up an interface to transmit or receive LLDP. Just a good thing to know there for yourself. Any questions about CDP or LLDP? By the way, you will read a large amount of things that tell you to always turn off CDP. Be very careful with that, because although CDP is a security problem or security issue, obviously, because if you're running CDP, you can get a lot of information on a device that's on the other side. The other problem is many times Cisco devices require CDP, like Cisco phones, in order to do registration, in order to set up the trunks they need for automatic use with voice over IP. So just be careful with that. You do have two different packet tracers, one using CDP to map a network and one using LLDP to map a network. So questions about CDP or LLDP, link layer discovery protocol?
So leaving them, I know it in the reading, like you said, I haven't got to this reading yet, but they're going to tell you to turn it off. But I would think that you only want to turn it off going out of your network and leave everything inside your network on. So you can, if you're in your network working on your devices, you can still see what's going on, but no one else from the outside can see. Is that correct?
That's correct. And also, if you are following the correct procedures with port security, then someone should not be able to plug in a machine onto a port and run CDP or LLDP because those ports are going to be secured. You know, if a port is set up to be with port security and one MAC address is allowed, even 2 or 3 MAC addresses, you're not going to have somebody plugging in a laptop and then running CDP to get information. So yes, that's my general thing is leave it off on the edges and in the core and inside, it's okay. And there will be other people to argue with that with me, but from a management standpoint, I think that's a good way to look at it.
Okay.
All right. So next thing is NTP, Network Time Protocol. Now, one of the things that we need to be able to do is if someone breaks into your network and you're doing logs and date and timestamps, if you don't set a time or if you don't make sure that the devices have the correct time, then you can end up with things like this. Okay. Now that one's actually correct because it pulled the clock off of the CML machine. But if it was a different machine, you can see this is March 1st, 1993. So if this was a production box and I was trying to prosecute somebody on breaking in my network today, I would go to court and they would go, well, Your Honor, my client wasn't even born in 1993, so how could they be breaking into this person's network? At that point, everything that you brought into court would be suspect. So one of the things we need to do is make sure that we set up our time correctly on our devices. It's also something that needs to be done, especially across Windows networks, because you get all kind of trouble with synchronization of the catalogs and those types of things. But on a router, you can set up NTP. And with NTP, there's basically different stratums. And stratum 0 is the atomic clock, basically. If you're set up, that is an authoritative stratum level. You can set stratum levels from 0 to 15, well, really 1 to 15 on a Cisco device because you can't set it up to be directly connected to the atomic clock. So the further you get away from stratum 0, the less trusted you are as a time source. But for the most part, we consider anything that's connected. The stratum levels, we're going to have stratum level 1 for our main devices. So we're going to set up one NTP server as a stratum level 1, and that's our primary network time standard for our network. And then everything off of that could be other NTP servers that are pulling information off of that stratum 1 device. So again, lower the number, the closer it is to the authoritative design or the authoritative time source. So for us, we're going to basically be using stratum level 1 and above for everything we do. We can also, one of the cool things about NTP is we can be an NTP server or a client. If we are a server, one of the things you can do, well, first off, if you're a client, you just point it to the server that's already an NTP server. This could be a Linux box in your environment. It could be another Windows box running NTP. It just needs to be a box that's running NTP. So this lets you connect as a client to an NTP server. And then there are ways, and that's pretty much all they teach you in here, but there are ways to actually become an NTP server. Let me pop out here. Pretty good little thing here anyway, but setting up an NTP server. So let's see what we got. I can find the actual. All I got here is the things with the, you're using GNS3, which is not technically illegal. Here we're setting up the time zones, which is showing our show clock. NTP broadcast is set up where it acts as a configure interface, act as an NTP server only. You've got to set your NTP master, and then that sets the stratum level. So you do NTP master stratum level. I think if you don't specify it, the default value is 7. The internal clock is 7. So, but typically you set it as a different level, and then that will tell you how trusted or how close to the master it is. But you can set it up as a master and then say what the source will be, the loopback, and then your other clients on the network can point to that loopback address. But they're going to have to be able to get to that loopback address. You can also have them broadcast it if you want to do that, but you can typically we just have them go pull it off of an NTP server. So in this case, we got an NTP server. You also can point it external to your network if you know one that's set to the atomic clock. But then you basically just pull out, go out all the way to the NTP server, and that will pull down your clock information. The big thing here is you want to make sure that whatever clock source you're using, it is accurate and it cannot be compromised, because that can be a big issue when it comes to prosecuting people who've broken into your networks. SNMP, Simple Network Management Protocol. Big thing here is talking about the fact that you have managers, which is your network management stations. You have agents that are loaded locally, and then those agents can send traps back to the SNMP manager. And they do that by looking at MIBs. And if you've ever looked at a MIB, what the MIB technically is, it's a list of things that can be either, SNMP can be used to not only report information via trap, but it also can be used to set things on a particular device. So the MIB would be like if you want to do, when you think about some of the things we'd want to see on a router. For instance, you want to see the clock. So we just did a show clock command. Well, in the MIB, there's a definition for how to get that clock information. Show IP in brief, there's a MIB entry that allows you to drill down and see the IP address on an interface on a Cisco router or switch. And then there are set items that let you use that same MIB to set different items on a device that's being managed by SNMP. Notice that the MIB use is UDP port 161 and 162. So those are 2 ports you need to know about. The SNMP is, by the way, UDP based. But here's some of the different things you can get: the GET request, retrieve a specific value from a variable. So for instance, the clock, the IP address, what OSPF version's running, those types of things. Get next, get bulk requests if you want to do large amounts of information. And then you've got different responses. So you can go in and get a MIB variable or set a MIB variable. So here's one. I want to know if G000 is up. And so you could go and say SNMP get, give me the status of that MIB item, and then it would return that information from your SNMP device or your device that's got SNMP running. SNMP, one of the big things about it you do want to know is you want to be running version 3 or higher, because version 3 allows for authentication, and also version 3 allows you to ensure that you are not, you don't have any issues with security issues that have been found and known. So SNMP version 2 has got some security issues that are known in it. So again, just going through here, looking at getting the information, get requests from specific MIB variables, and then setting items from specific MIB variables. So here we see SNMP v3 is the only one you should use in a modern network because it does allow for authentication, and it also has fixed some of the other security issues that have been found in SNMP version 2. Don't ever, by the way, community strings, it's one of the things in SNMP public-private were the default community strings. Don't ever leave your default strings if you're using SNMP, okay? Because you do have the read-write and the read-only community strings. If you have those, then it is possible actually to send information to make it to configure a device with read-write, which is very dangerous. And this goes into a discussion of what a MIB object ID is, how it goes all the way down through and can be certain variables, certain interface groups. The MIBs are based upon the device themselves. So if you go out there and look at Cisco device MIBs, there's going to be a set of MIBs for each version of the iOS and the capabilities of the iOS and the capabilities of the device. So, and here's an example of polling, going out and pulling information. And I'm not going to spend a lot of time on that because it's not all that big a deal, right? As part of network management or the other, because we don't use as much today with SNMP as we used to. Now, Syslog is something that's important, and that is because we use this to send our logs to in order to be able to save them in an offline format. It also allows us to see where things are being sent. This is an important area I will tell you need to spend some time reading, paying attention to. But by default, we log just to the console line. So that is by default. There is an internal buffer you can do it. You can actually send them to. You can send them out a terminal line, or you can send them to a Syslog server. The terminal line is if you're connected via VTY lines. But our option we're talking about now is sending them to a Syslog server. And as part of this, you set what's called a logging trap level, and that will say how much or what level of items get sent to the Syslog server. Cisco has set these 8 different levels. Basically, the higher the level is, the less critical the item is. I would never log debug level information just because, not continuously, because you'll have so much information in your logs. A lot of times we do informational messages down. It just depends as to what you're trying to do. Now, if you are actually debugging something and you need it to be logged into the Syslog, then you need to change your logging trap level. And I'll show you that in a minute. But basically, here they are. You can set up different mnemonics as far as what it is. So link up, down. So this is a level 3. So if we go back up, we'll see that that is an error condition. Okay. And so we've got interface port channel changed to up. So it's severity level 3. The mnemonic is up, down. So in other words, it's called either up or down. And so this is one of the most common messages saying that, hey, error condition is either up or down. So you'll notice it's not really an error condition so much in the fact that it went from up or down to up, but it is making you aware of it. And again, you can do your timestamp. So you can do service timestamp, log date, time. This makes sure that all of the entries that go into the Syslog server are stamped with a time and date. And that's why it's important that you have NTP or at least have your clock set correctly on your devices. And then you can actually just push it out to a Syslog server. And there's a Syslog server command. And again, this used to be we had to actually configure that. We don't have to configure that anymore, which is kind of sad. I'm not going to spend a lot of time on this, but basically the Cisco iOS has a Linux-based file system for the most part. If you do a show file systems, you get to see all these different things. One of the things that's useful is this USB 0 If you do have a USB port on the router and you put a USB stick on it and it has the iOS on it, you can actually boot from that iOS, and you can copy items from the USB into boot flash. So if you're updating the iOS, you can do that. Uses the directory command. You can use dir to see what's in the boot flash. So if you do dir by default, it will just show you what's in boot flash, which, by the way, you've read a lot about flash : on these newer routers, the 4000 series. You could put dir flash : there's an alias that says that flash and boot flash are the same. However, on some commands, they are not interchangeable. So with these newer routers, I would just start using boot flash : just to be aware that that's important. And then NVRAM is where your startup config is stored. So you can actually go into NVRAM, non-volatile RAM, by changing directories. Look at your present working directory, again, showing as Linux commands. Shows you an NVRAM, you do a directory. And I actually think you can even do an LS, but I'm not certain on that. On some versions you can, on some you can't. And so again, backing up our configuration files, we can do a show run and then just copy it out, or you can also log it out using something like TerraTerm. I like to just do a copy or show run and then copy it to a Notepad++ personally. You also can do this, copy, run, and config to TFTP. And one of the things I always tell people before they try to back up configurations, before you ever try to TFTP anything, be it the running config, the backup, the startup config, or the iOS, make absolutely sure you can ping the TFTP server before you try copying anything to it. Because typically if you can't ping it, you can't copy to it. So make sure you have connectivity to the server that's running TFTP. And then you can copy it there. And here's a discussion of the USB, which is a very good thing to have, especially since in the old days we didn't have that. We also have a USB here. You can see you can use management, or you can use a USB mini to do connect and do your management. A lot of them also have just a USB port that you can use to copy files to and from the USB. So you can do a copy, run, and config USB flash 0:, and it will copy the running config with whatever name you give it out to it. So you can save a backup to the USB. You also can copy iOS images from flash into, or boot flash onto the USB drive. I'll let you look through this password recovery procedure. It's pretty easy. Big thing is hitting the break key at the right time. So for PuTTY, it's control break. For others, you also in PuTTY can right click and go break. That's something you can do. But you can go through and read about this. And this is if you've forgotten your passwords or can't get in your passwords. This will allow you to actually recover without deleting the configuration. You actually save the configuration using this process. And then we have a bunch of labs for you to do. And last but not least is looking at how to back up our iOS, our full iOS. And it is just literally you ping the TFTP server first, and you do copy flash : TFTP. Make sure the source file name is whatever the name of the iOS image is in flash. You want the IP address of the TFTP server, so your remote host. And then you can just, that should be populated automatically if you put in the correct name up here. And then you hit enter, and it will then take time and it will update those. There is, I sent out to the class, I'm fairly certain, but on my YouTube page, I actually have the process for upgrading the iOS on Cisco 4000 series routers using the USB. So it is possible to do that, which is pretty neat. Are there any questions about managing your network? NTP, CDP, LLDP, any of these that you have questions about? All righty, well, I'm going to stop sharing my screen, and I'm going to stop the recording.